What's up, math addicts? Welcome to another episode of Mathtastic. This is episode 2 of season 2 on order of operations. I'm so excited. I know it's a weird thing to be excited about, but I am. I can't help myself. The reason I'm so excited is oftentimes when math teachers are talking about order of operations, we tend to rush through it because we want to get on to other things. But there's a lot of nuance in order of operations that's going to really help you down the line. So we're going to use order of operations this whole season to both really master it and also to talk about the individual components of it and to look at them in relation to each other. So with that, we're going to start with parentheses if we're talking PEMDAS, or groups if we're talking GEMS. And let's talk about what that means first off. And why are there two different mnemonic devices? Well, this is a big reason why. Uh, so let's look at PEMDAS really quick. I said in episode 1 that PEMDAS was the way that is the mnemonic device, meaning it's how we remember a certain how we remember something, how we remember anything. Sometimes people would teach this, please excuse my dear Aunt Sally, PEMDAS. And the P stands for parentheses, and it meant that to do whatever is inside the parentheses first. And then we talked about in episode 1 that this has been updated, and now teachers tend to teach this mnemonic device GEMS, GEMS, groups, exponents, multiplication, subtraction. So the first big difference that we see is that PEMDAS starts with a P for parentheses, and GEMS starts with a G for groups. And this is now the preferred way. So let's do a little bit of a dive into why that is. First off, we talked about how something like this, first off, these are called numeric expressions. It's numeric because there's no letters in it. This is numerical with all numbers, and it's an expression because there's no equal sign. If there were an equal sign here, if this were equal to X, or if they told us this was equal to 11, we would call this an equation. With that said, we might be tempted to approach this by adding first, but that's not what order of operation tells us. Order of operation tells us multiplication comes before addition. So we want to multiply first. This would be 3 plus 8 or 11. Okay, but what if, as the writer of this mathematics, I do want you to add first? If that's the case, then I need to turn this into a group. And to do that, I'm going to use parentheses. Now I have 3 plus 4 is 7 times 2 is 14. It worked differently because parentheses comes before multiplication. Okay, so why is this, why do we switch it from parentheses to groups? The reason for that is there are other moments when we might see other notations that we might see to denote a group besides a parentheses. So let's say I have this. I have 4 times whatever's going to be inside this parentheses. I'm just making it up now. 3 times 2 plus 8 parentheses. Okay, so it says do what's inside the parentheses first. I look inside the parentheses. I see 2 more operations, multiplication and addition. Might be tempted to do the multiplication first, but there's another parentheses. So I'm going to do what's inside that parentheses first. So this is 2 plus 8 happens first, 10 times 3, 30 times 4, 120. That's not important. What's confusing about the way I wrote this is the double parentheses. And there will be time when we have a group inside of a group and we need to use a double parentheses. But what some math writers will do is, instead of using the outside parentheses as parentheses, they'll use brackets. because it's a little bit easier to distinguish which open parentheses or which open group goes with the other open group. This is one group. This is the group within the group. So brackets count the same as parentheses. We want to do the inside one first, not the outside one. You don't want to do this multiplication of 3 times 2 before you add them together. So when we see brackets, it's a group. It happens first. It functions the same way as parentheses. But this is not the only time you might see a group. There's another notation that functions as a group. Do we remember what this is? These are absolute value signs. By that, I mean these two straight lines. Let me not use 11 because that just makes it really confusing. Let's use a number like, I don't know, 22. I like the number 22. These are absolute value signs. So these two straight lines that happen outside, they're like parentheses, except instead of being curvy, they're straight. And they function similarly to parentheses in that they do make a group. So if I have this 4 times the absolute value of 8 minus 22, I want to do what's inside the group first per order of operations. For absolute value, what is 8 minus 22? I don't really remember. Oh yeah, it's negative 14. Closed group. The difference between the absolute value sign and the parentheses is that there is an added functionality. The absolute value sign turns any negative number positive while keeping any positive number positive. So this will be 4 times a positive 14. 60 is 56. Positive 56. This is not a lesson on this function of the absolute value sign. This is just to point out that the absolute value sign has it can also be considered a group, and with order of operations does need to be performed first, whatever's inside of it. Okay, and then finally, and this is the one that really messes with people. If I have something like this, oh my gosh, a fraction. Uh-oh. Okay, we're not going to do a deep dive into fractions right now, I promise. But whenever you see a fraction, no, and if there's multiple terms on the top and the bottom in the numerators or in the denominators, know that we assume there to be a parentheses here. So you might have heard that the fraction sign in some applications, it's easy to think of it as division, and that's true. And we do want to do division before subtraction, but even if they're not written in, we assume there to be parentheses in the numerator and in the denominator. Okay, so 3 minus 2 all over 8 minus 5. Before I do anything else, I want to do this subtraction. This is 1 over 3. It might be that there is a multiplication happening here. This is not 2 times 3 or 2 times 8. This is 2 times 1/3 because we assume that there are parentheses in the numerator and all over the denominator, making this a group. Okay? All right. So that was our breakdown of the first component, the P and the G of PEMDAS and groups, respectively. We went from the P and we started calling it a G instead because it's not just parentheses. It's also brackets. absolute value signs, and anything happening in the numerator of a fraction or the denominator of a fraction. And I bet there's more that I'm forgetting. I just can't think of them right now. Okay. Thank you for being here. In our next episode, we are going to do a super deep dive into exponents. We're also going to integrate exponents into groups and talk about why groups really matter when we're talking about exponents. And we're also going to look at it in context of multiplication as well, because all exponents really are as a shorthand for multiplication. All right, I will see you then. Thank you for being here, and I will see you in episode 3 of our season on order of operations. Ciao.